Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and by.
For more than 7 decades, PLN has carried out the state's mandate to electrify the whole Indonesian archipelago. With an installed power generation capacity of more than 75 gigawatts, PLN serves more than 90 million customers in sharpening its vision as the leading electricity company in Southeast Asia. And as the #1 customer choice for energy solutions, PLN continues to develop programs on an ongoing basis, strengthening its role as the heart of Indonesia for the sustainability of energy supply and the transition to renewable energy. Now, PLN is entering a new chapter in its transformation, aiming to become not just a power and utility company, but also a technology company based on innovations. All of this is to improve service quality, strengthening the domestic industrial ecosystem, and increasing competitiveness in the global stage. The new PLN 4.0, unleashing energy and beyond.
Jaga bumi kita itu mudah. Dari yang kecil bisa jadi besar. Dari sampah bisa jadi sesuatu yang berguna.
Kita juga harus peduli dan melindungi mereka biar tetap lestari. Dari menanam pohon di taman sampai jadi hutan.
Terus menjaga agar kita bisa tetap melihat mereka yang langka. Ini energi kita
Yang semangatnya nggak pernah berhenti.
wujudkan mimpi-mimpi lewati imajinasi.
Buat rumah yang asri untuk kita dan mereka. Bersama berjuang untuk bumi yang lestari.
Dengan teknologi gerakan tiap energi untuk menjaga bumi,
Membuat kita bangga jadi bagian dari Indonesia.
Kehidupan terus berjalan, bergerak, maju. Perkembangan teknologi, geliat pembangunan infrastruktur, industri yang tumbuh dengan pesat, dan kami menjadi bagian dari pergerakan itu, pergerakan menuju kemakmuran. Dari sebuah langkah kecil di 2021 hingga sebuah lompatan inovasi untuk menyongsong masa depan. Di tengah cepatnya arus informasi dan kemajuan, bagi kami satu hal tetap sama. Standar keselamatan dan kualitas selalu menjadi yang utama. ID Survey hadir sebagai sebuah kolaborasi kekuatan dari perusahaan yang mempunyai passion sama, mengutamakan kualitas, akurasi, dan ketepatan dalam industri pengujian, inspeksi, sertifikasi, klasifikasi, dan statutoria. Bekerja sama dengan rasa tanggung jawab yang besar, membawa kami tumbuh menjadi perusahaan terbesar dan terpercaya, menjadi perhatian dunia. Mendedikasikan seluruh usaha untuk meningkatkan kualitas hidup melalui layanan kami. Memberi kenyamanan dan rasa aman dalam setiap aspek kehidupan sehari-hari. Di setiap perjalanan yang nyaman, dengan tetap mengutamakan keselamatan. Di sebuah kenikmatan yang sejalan dengan keyakinan. dalam kualitas produk bertaraf internasional, namun kental dengan kandungan lokal, hingga melakukan jasa konsultasi, supervisi, dan pemeriksaan berbasis green ecosystem, menjadi one-stop shop layanan dekarbonisasi dalam ekonomi hijau untuk kehidupan yang berkelanjutan. Merevolusi sebuah sistem kinerja dengan berlandaskan pada nilai-nilai perusahaan, akhlak. Dedikasi kami bukan sekedar memberikan jasa layanan, namun juga berjasa kepada masyarakat, terus berkontribusi sebagai penggerak kemajuan bangsa hingga tercapai masa depan bangsa yang membanggakan. ID Survey, we building your trust.
YouTube belum? YouTube udah. Ya, record juga udah. Tulisannya sih recording.
Ladies and gentlemen, ICSEEA participants, we would like to invite you all to come to ballroom because we will start our event today. Before we start, we would like to remind you about the conference rule. Online participants, please make sure your microphone is muted and only unmute when being asked or very necessary. Online participants are required to join the virtual room 15 minutes before the session start, and please rename your Zoom name to article ID _name_session. Online participants must activate the camera and use the official ICSEEA 2025 virtual background. Online participants, please choose a quiet, distraction-free location for attending this conference and ensure proper lighting for your video setup. During parallel sessions, please follow the allocated time. The moderator will remind you when your time is almost up. During parallel session, participants are expected to remain in their respective rooms and stand by waiting for their scheduled presentation. Please avoid taking screenshots or photos of presentation slides belongs to other presenters during the parallel oral session. Offline participants, please check the program book file for a reference of your respective room. Offline participants, please note that slideshows will be managed by the committee and cannot be presented using your own laptop. Kindly ensure that you have uploaded the correct file. Online participants, the committee will assign you to your respective rooms. Once your session is complete, you are welcome to join a different room by clicking Request to enter for your desired breakout room. Lastly, the best paper and presenters will be announced at closing session, so please join all the agenda and do your best. Good morning. Selamat pagi. Assalamualaikum warahmatullahi wabarakatuh. Welcome to day 2 of the 12th ICSEEA 2025 International Conference on Sustainable Energy Engineering and Application with the theme Green Manufacturing, integrating renewable energy and advanced testing technology for a sustainable future. Thank you for joining again after a very long day yesterday with a lot of interesting and insightful research and innovation related to renewable energy and advanced testing technology. Allow me to greet again our honorary guests and speakers. Professor Cuk Supriyadi Alinandar, Head of the Research Organization for Energy and Manufacturing BRIN, Heads of Research Centers under the Research Organization for Energy and Manufacturing BRIN, Dr. Adroit Torik Nur Fajar from Kyushu University, Japan, Professor Anneli Petrisan from University of Lorraine, France, Dr. Ismail Abdullah Al-Faleh from NMCC SASO or Standards Metrology and Quality Organization, Saudi Arabia, Dr. Masahiro Hori from Research Institute of Electronics, Shizuoka University, Japan, Mr. Onodera Hitoshi from Japan Automobile Standards Internationalization Center, Dr. Tatsuya Nikuni, Director of the Environment Research Department, National Traffic Safety and Environment Laboratory, Japan, Mr. Tim Lehman, Par Instruments, USA, Mr. Rahmat Hidayat, PT Hioki Electric Indonesia, Chairman of ICSEEA 2025, Muhammad Hoirul Anam, PhD, our sponsors, Par Instrumen USA, PT Sarana Laboratorium Instrumentasi, PT Hioki Electric Indonesia, PT PLN Persero, PT Pertamina Persero, PT PLN Puslitbang, PT Geodipa Energi, Biro Klasifikasi Indonesia, PT PLN Indonesia Power, PT Vale Indonesia, PT Bank Pembangunan Daerah Jawa Barat dan Banten. Our event partners, Gajah Mada University, UPN Yogyakarta, Universitas 11 Maret. Again, thank you for supporting ICSEEA 2025. Your support is truly valuable to us. Finally, to all distinguished participants of ICSEEA 2025, thank you for being part of this conference. Let's give a warm round of applause to everyone. Ladies and gentlemen, our agenda today mainly consists of one plenary session with 3 speakers in total, followed by the industry session. We will have 2 speakers, followed again next by oral presentation in parallel rooms, both offline and online. We kindly ask for your cooperation to ensure that this conference proceeds as planned. Okay. Ladies and gentlemen, to capture the memories of today's event, we'd like to take group photos together. So I invite you all to come to the stage and maybe some of you in front of the stage so that we can take photos as a group. Please, welcome. Thank you, everyone, all the keynote speakers, head of research centers, and our sponsors, representative, and all participants. Maybe some committee also can join. To the photographers, please stand by. Maybe some of you can stand on the stage and some of you can stand in front of the stage. And photographer will check if we can see, we have to make sure everyone is visible. Oh, Pak Chu. Ya, Bapak di bawah aja. Maybe for keynote speakers and Professor Chu and head of research centers, in front of the stage, while participants, could you please go to the stage? Yeah. Yeah, okay, maybe some of you, because we don't have enough space here, so maybe some of you, can you go up to the stage, please? I can see beautiful batiks today. Also a very beautiful traditional Japanese custom. Srojan ya, apa namanya? Sogan. Also sogan, very beautifully wear. Maybe for committee, can some of you please go to the stage? check, check. Chairman. Okay, can you see everyone? Is everyone in the frame? Okay, photos first. 1, 2, cheese. 1, 2, 3. Give your best smile. Cheese. Okay. Okay, we need one more, one video for today's. Oh, different pose. Okay, because I don't really can do anything here, so that's why. Okay, maybe put your hand in the air, like Pak Cu, tolong dicontohkan. Yeah, yeah, like that, everyone, so that we can show our excitement of joining today's session. Okay, cheese. 1, 2, 3. All right. Okay, I have one request. We would like to have a video again for today because I know some of you did not join yesterday and you joined today. We have a like kind of slogan. When I say, can you turn the music down, please, a little bit? Sorry. Yes, thank you. ICSEEA 2025, you say what?
Sustainable future.
Oh, great. So he's following. Nice. Sustainable for a sustainable future. It's our theme, okay? For a sustainable future. When I say ICSEEA 2025, all of you say, yeah. And then you put your hand in the air again, okay? As loud as possible, okay? Make this room shaking. All right. ICSEEA 2025 for a sustainable future. Okay, that was a practice. Okay, we have to do again one more time. Okay, this time do your best. Oh, Bapak Geodi. Selamat datang Pak Yudis dari Geodipa. Boleh langsung bergabung Bapak. Nggak usah lari Pak, nggak apa-apa Pak. Enggak Pak, ya kita tunggu. Di tengah Bapak silahkan bergabung dengan di sana boleh Pak. Iya. Pas banget Bapak datangnya ya, pas di waktu foto. Just right moment. So when I say this time no practice, okay? I say 2020 ICSEEA 2025. All of you say for a sustainable future. Loud as possible. Okay. Ready? Are you recording? All right. ICSEEA 2025 for a sustainable future. Great. Thank you. Give applause for everyone. You can return to your seat.
Sekarang apa? Ke jalan. Sekarang saya pakai wifi. Mudah-mudahan nggak ada. Tadi udah protes.
For this session, we need to prepare a little bit. Please wait a little bit. And I would like to also confirm if my voice can be heard by online participants in Zoom. If you can hear my voice, please let us know. Okay, great. Thank you. Cek line dulu, kamu langsung jalan aja. Okay. All right. ICSEEA participants, let's begin with our first session. We will have 3 speakers, Dr. Ismail Alfaleh, Mr. Masahiro, PhD. They are here with us in this room, while Dr. Tetsuya Nikuni will be joining online. I would like to check if he can hear us. Nikuni-san?
Yes.
Can you hear us? You can send message
you.
or answer.
I can hear you.
Just to make sure that you are standby.
I can hear you. Can you hear me? No?
Yes, I can hear you, but wait a moment. We are adjusting the volume to make sure
Okay.
all the audience here can hear you.
Okay.
Okay, nice. We can hear you clearly. And I would like to make sure we can also see him video. Okay. We are setting up a little bit. Is the screen share is not working right now? Yeah, there's always something, you know, every day. Very natural. Okay, Dr. Nikuni, please wait a little bit. We need to know if we can see you, and we are now setting up the video again. We already checked this morning earlier. Should be okay. Can we see him? Because I can't see him yet. All right. Okay, there you go. Yeah, now we can see you. Yes.
Hello.
Now,
Morning.
can you see me?
Yes.
Okay.
I can see you.
I'm Novi. I see you enjoying your coffee. Very nice. We are also enjoying our coffee here.
But I
Okay.
don't.
Okay, so later our moderator will introduce all the speakers and including you, and then you can start your session. You will be the third speaker, okay? All right, so this session will be chaired by our moderator, Dr. Hans Saputra. Now I would like to invite Dr. Hans, Dr. Ismail, and Mr. Masahiro to the stage. And yeah, of course, Dr. Nikuni will stay online. Please welcome. Please give applause to all the speakers and the moderator. Okay. You will have your clicker and laser pointer ready this time on the table. Okay. Please, Pak Hans.
Ya. Oke, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Hans Saputra. I will be the moderator for this plenary sessions from 9 to about 11 o'clock. And I am principal engineer and also the head of Research Center for Process and Manufacturing Industry in BRIN, National Research and Innovation Agency. It's also a great pleasure and honor for me to moderate these sessions. See you again on the second day of 12th International Conference on Sustainable Energy Engineering and Application 2025, ICSEEA 2025. And with the theme, Green Manufacturing, Integrating Renewable Energy and Advanced Testing Technology for Sustainable Future. This international conference is conducted in hybrid setting. Therefore, I would like to welcome those participants who are joining us virtually. We wish you could join us well and comfortable in attending our agenda today. This is opportunity for us to gain the knowledge and experience or lesson learned from the incredible speakers today. And now we have 3 incredible speakers here, and we'll give the presentations about 30 minutes for each speaker, and also allocated time for Q&A sessions later, totally about 20 minutes as well. Before presentation, I would like to introduce all of our speakers. The first speaker is Dr. Ismail Al-Faleh. Good morning. Yes. He is from NMCC SASO, Saudi Arabia, or the National Measurement and Calibration Center. It is part of the Saudi Standards Metrology and Quality Organization, or SASO. He will present about the role of metrology, standards, testing, and quality of standardizations in energy and manufacturing in Saudi Arabia. Then the second speaker, Mr. Masahiro Hori. Good morning, Hori Sensei. He is from Research Institute of Electronics, Shizuoka University, Japan. He will present with the title, Nano Manufacturing for Energy Saving Applications, Energy Saving Techniques for Cryogenic CMOS Technology. Then the third speakers will present online, Mr. Tetsuya Nikuni. Hello, Nikuni-san. Do you hear my voice?
Yes, I can hear you very well. Thank you.
Okay, thank you very much. Mr. Tetsuya Nikuni is from the National Traffic Safety and Environment Laboratory, National Agency for Automobile and Land Transport Technology, Japan. And very interesting, he will present with the title, Outline of Activities Aligned with Japan Strategy and Vehicle Towards Carbon Neutrality. Okay, ladies and gentlemen, now we begin with the first speakers, Dr. Ismail. Please, time's yours. Yes, please. Okay, this is the pointer. Next and please.
السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. رسول الله. Sorry. It's okay? Okay. Sorry for that. Okay. As our moderator said, my name is Ismail Al-Falih from Saudi Arabia. I will first start with thank you very much for the organizer for this international conference, for inviting me to give these short talks about, let's say, standardizations and metrology and quality and testing in Saudi Arabia, and give you a case study, a short case study regarding the renewable energy in Saudi Arabia and the manufacturer done on the renewable energy in Saudi Arabia in the very short moment of time. First of all, I would like to beginning with my subject actually, which is the metrology sessions. And I would like to explain a little bit about the metrology itself. The metrology actually, it's categorized in the three fields exactly. It's the scientific and industrial and legal metrology. In Saudi Arabia, we start with the legal metrology recently. It's, of course, it's been there from long time, but as an officials, it started actually, and recently it was beginning with 2018. The legal metrology actually, it's very important for consumers in the market everywhere, and they are use it. The programs running in Saudi Arabia try to cover all the aspects about the legal metrology in Saudi Arabia, including even the simplest weighing balance used in the market. And they running in a plan, very well planned. From the beginning, they start with the electricity and water meters. After that, they jump to weighing balance in the very important goods like gold, or even the herbs like oud and saffron and different types. After that, they went to far away for planning for even the traffic speeds camera, and also weighing scale for trucks, and the planning going well. After that, in the industrial and in scientific metrology field, actually it's focused by the National Meteorology Institute, which we call it NMCC, National Measurement Calibration Center, which is located in Riyadh in Saudi Arabia, and focusing on the scientific of metrology field, and cooperate with all ministry and organization in Saudi Arabia, especially from the government side, and also cooperate with the other institute, research institute in the kingdom, such as the King Abdulaziz City for Technology and Scientific Research. This is a brief introduction to the metrology. After that, we jump to the standardizations and we explain the metrology actually. What's very difficult to see from here. Okay, we jump to the energy and manufacturer and the metrology supporting energy and manufacturers. Actually, our aims to support the energy and manufacturers. Maybe everyone knows Saudi Arabia, it's a petroleum country, and we are working with the oil a lot, actually, and we are working side by side to the company who's working with the oils, and also the Ministry of Energy. And the Ministry of Energy, actually, we have so much cooperation together between us and them, especially not for research, unfortunate, but we are focusing on delivering the calibration for their instrument. And also now we have a mega project regarding the fluid calibration systems, and we are working together to track this strategy for really long times. Looks like around 10 years in ahead. So we are aiming for these programs, and still it's ongoing for the importance of the fluid systems in the oil company. And also we are working with the organization which called the Water Organization in Saudi Arabia, because the shortage of water in Saudi Arabia is really challenging for all the kingdom. As you know, we are a desert country, so there are very shortage of water there, and we need to focus on it. And also Saudi Arabia, visitors from all the world, it's reached almost 100 million yearly. So the consumption of the water, it's high demanded in Saudi Arabia. So we are working with this organization to set up for the calibration. The master meters, they already have it, because we are taking our water mainly from the sea by dissolving these waters. For the manufacturer in this field, we are working, as I said, our legal metrology now focusing in electric and in water meter. In the electric and water meters, there are now starting manufacture smart meters in Saudi Arabia. So we are working with them side by side to try to estimate the right accurate measurement for each meters, but we are not doing for each meter. Actually, this is another side of the story. We are doing the master meter for them, or the power and energy systems, what they have. Then we do the service for them. Next. Okay. Okay, that's great. The import, no. Yes. Sorry. Okay, the importance of standards. The next subject, it will be focusing on standards and the standardizations. In Saudi Arabia, the standardization, it started like more than 40 years ago, the government established the SASU, which we call Saudi Standards and Metrology and Quality Organizations. And it was established on the Riyadh, capital city. After establishing, their main job was focusing on standardization and adoption all the standards coming out from the international organization. After that, we actually create a way of creating Saudi standards, and we starting with the creation of the Saudi standards by a special, it's actually international way. It's creating a team from start A to start to the end of the standards. And it's continuously working and making so many working group to focus on each standards and each individual standard, which help our economy in Saudi Arabia. As you know, the important of standards for everyone, the most important, the standard for everyone, which help the goods and trade in Saudi Arabia. So we are working with international organizations, so we can allow for our goods to go smoothly in other country, and also for importing other to our country, which make it easier for conformity system in Saudi Arabia. This is the short list actually for how we create the standards, but in Saudi Arabia, we are creating the standards by starting with, let's say, the research. The research, it will be start not just from the research center. Actually, it's coming also from the consumers, coming from the manufacturer, coming from anyone needs standards, and they apply for a type of standards. And who will apply for this type of standard? Everyone welcoming to apply for any standard you are needed in your manufacturer or you are needed in your organization. After applying for this request of a standards, we shift to create a team for these standards, for particularly these standards, which we will call it working groups for standards, and specified on the type of the standards we are working on. Then after that, it will be the reviewing, it will be reviewed from specialists working in SASU and from other cooperation or other organizations SASU are cooperate with, either the national or international organization from outside of Saudi Arabia. After the reviewing and understanding the need of the standards and put all the criteria we are needed in the standards, we upload it to the approval of from the high governor of the Saudi standards. After that, go to the council for approval to be a national standard. This is the way we are creating the standards. To be sure, these standards are working and it's been applied to what's been made for it, the quality assurance, or not the quality, the quality assurance and testing for these standards, we are applied it. The SASU got several testing laboratory inside the organization, and after they apply it, we have in Saudi Arabia ranking actually for all the goods which will follow the standards and follow it for it. So each year's our testing laboratory go in the market and collect these goods which following this type of standards and do the tests on the way of the standard mentioned. After that, the ranking will mention how much our goods in Saudi Arabia are matching the standards being created in Saudi Arabia or adopted in Saudi Arabia from the International Standards Organization. For conformity assurance, laboratory testing as certification and inspections. As you know, we create a smart way or digital way. We call it sometimes Saber. Saber actually joined all these together in one platform, either from inside or from outside. So if you are businessman, you want to export your goods to Saudi Arabia, you need to go through Sabers, which will require some inspections, some test laboratory, some certification, and you can apply for these systems. After that, you will get the approval. Sometimes it will take, or most of the times, actually, most known goods will take just like a couple of hours to complete and to be accepted to go to the Saudi market, which is the right way for everyone. And also from inside, also they need to apply for that so they can confirm their quality of goods are so good and it's acceptable in Saudi Arabia. Okay, for the quality, we have actually, this is just mentioned the type of quality you needed in your manufacturer, but in Saudi Arabia, we have the quality mark, which we call it the quality mark, and it's coming from the SASO organization. The quality mark also, it's required so many standards to be accepted for that. And we are force the quality mark in certain type of products, that kind of product which are the most important and safety for our nations, and also for the goods coming out from outside, such as the electric connections, which is really important and make huge safety issues. That's why we enforce the quality mark of Saudi Arabia to that issues, and you have to get it for your productions line and product. As we mentioned, there are 4 categories, which is the metrology and standard and testing and quality. All of them are cooperative together for the one product. If you take one product, you make sure there are all these several categories and more are cooperating. You cannot separate one out of other. Such as the metrology, you cannot separate it from any production, from any research center. So you need to be sure and you need to be accurate about your measurement, about your results, about your final certification for the result you are looking for. Then after that, also you need to follow some kind of standards, which mean required for your type of jobs, for your type of products coming out from the manufacturer. You need to be sure they are acceptable in another place where are they going to be used. And for testing, this is testing for reducing your loss, because if you are just going to product, that's mean without any testing, without any reviewing, that's mean you are losing so much regarding the misaccurate measurement or unfollowing the standards. And if you are transporting to another country, if you are not following their standards, that absolutely it will be a big loss for your manufacturer. So it should be all these three things, four things being followed and being accurate in your organization. Okay, I put short list regarding the challenging on the MITSET, or metrology and standard and testing and quality, which is this short list just contain four of out. I don't know how many actually. There are so many. Every country, every organization, every manufacturer facing these problems with shortage of expertise. And we are facing a lot shortage of expertise and technology adoptions. We are talking about every time talking about the technology adoption nowadays. Even the BIBM in Paris are talking about adoption, the digital transformation and all the digital transformation and the AI systems, which we needed and we should follow it. That also makes a huge pressure on the organization, especially on the National Meteorology Institutes and other related organizations. After that, I put the culture shift between one country to another. There are so much diversity in the culture, which is good actually, but for creating something, that means you need to also see the culture on that country, what they are looking for, what they're using for, and not finally actually, but the finally on my list, it's the competition between all the organization and the production lines. So sometimes you see the production lines in very good quality coming out from another country and imported to another country, which will be competitive to the what's being produced in your country. This is actually the short one, but there are so many more challenging which can be explained. But I feel this is the most important of them. In Saudi Arabia, actually, as I said in the beginning, the government established SASO 40 years ago. After that, establishing the inside SASO divisions such as the metrology, the testing and quality assurance, and also conformity systems, and also accreditation, but now accreditation is separate from the same organizations. So SASO, or Saudi standards, it's the umbrella for so many institutes inside it, which is make it more challenging for Saudi standardization. But the challenging in that it was make it an opportunity for us to start with a creative ways, such as the standardization. We are adopting so many standardization from the global, especially from the International Standardization Organization, ISO or IEC or IEC-EE, and all other standards. And we are also open for national standard in other country, which could be helping and processing in Saudi Arabia. As I said, the government supports all these entity inside SASO. So it's been a governmental organization without any support from the business or from outside of the government. Okay, maybe you hear about Saudi Vision 2030, and it's focusing actually on 3 pillars. The economic diversity shifting, which is not only the oil, we are shifting to another economical aspects, and after that, innovation enablement. So we are actually reaching a good innovation, especially in the new advance of the digital transformation. And if anyone visits Saudi Arabia, he will be surprised how many applications and how many easier access to many government institutes through the digital transformations. Especially, you can even like renew your passport without visiting any office, just at your home, banking at your home. All these things been adopted. And global competitivity also, we are trying to invest as many as we can in the infrastructure of Saudi Arabia. And we are more open nowadays for all the world and welcoming everyone to visit Saudi Arabia, especially for tourists or either for Muslims country. We are more open for them to visit Saudi Arabia, and not only doing like Umrah or performing Hajj, but also they can also invest in Saudi Arabia in such way they can. Okay, I will shift now to the case study for renewable energy in Saudi Arabia. Maybe my shift, it will be a slightly explanation without any deep details in the renewable energy. I will explain some like short story. You can see the farm here actually, and the highway this. It's starting from 2018. And not only this one, this is just one case out of almost 30 farms similar to this. There was a big challenging to adopt solar energy systems. There are so many difficulty in Saudi Arabia, actually. The difficulty of the heat, it's very hot in the deserts, and the difficulty of the sand storms, and even the dust covering all the panels, which make the efficiency is very challenging about that. But we start, the government start the programs during these visions and established a institute for studying and creating and manufacturing all the solar cells. So most of the solar cells being used there in Saudi Arabia are being manufactured in Saudi Arabia, which will adopt for our weather technology. And the name of each farm, it will be named, sorry, I don't know if you can see the name, Sudair Solar Photo Voltage, which is really a great place. And I pass it almost every week, because it's not in the capital city. It's like 150 kilometers from the Riyadh, and I'm traveling every week, almost every week, from Riyadh to my hometown to visit my mom. And I pass it, and I feel it from the beginning, actually, from the scratch, from nothing after until now. It's actually producing a huge power, producing almost like, I think, yes, 150 megawatts. It's producing 1,500 megawatt. And it's been used, most of it actually, it's been used for manufacturer, because there are another manufacturer institute city nearby, and most of the production coming out from these farms goes to the manufacturer. That's why make it in the vision, so we can help also the industrial field and all the need of the power from the industry. This is another farm which call it SCACA for photovoltaic, and it's a bit far away from Riyadh. And most of these farms are using the technology nowadays, and most of this technology being produced in Saudi Arabia, like cleaning, robotics, which we needed actually. And it's not, we don't use mostly water, we use other way like blowing air or something like that. And this cleaning systems, it's running 24 hours, so we can keep these systems working, and also tracking systems for each panel have its own tracking systems, so we can get all the efficiency or the efficiency we are looking for each panel from this. As I mentioned on the Saudi Arabia, if you see, it's wide diverse, and it's wide in the country of Saudi Arabia, and you can see it almost everywhere. And most of the consumptions coming from the industrial field, and most of the industrial field now rely on this photovoltaic power coming out. The luckily things actually in some area of Saudi Arabia, they don't need actually the high tech for the looking for the panel systems, because the panel systems the weather are much good for them to work, not like working in the desert on the Sahara. So they are more efficient. For the standards, I will try to just follow up quickly. For the standards, as I mentioned in the beginning, to create a standards, we are getting requests or building a research team, and starting with this starting with the project. The project, it will go under the strategy of standardization, of national standardization. And we are talking with other entities in Saudi Arabia, so the other can be involved, everyone involved in the standards, it's follow their system. And this is the kind of standards for renewable energy, but we are talking about solar panel, but there are still working with batteries and the turbine, and especially with batteries, because we cannot import the battery from outside, because we have to make sure they are safety for the weather of Saudi Arabia, because if you measure the road temperature, it's really high. It's reached sometimes 70 degrees Celsius. So it's make it big challenging for other production of the battery, lithium batteries in Saudi Arabia. So it's still have higher standard for this kind of protection for the battery. This is very quick. For the metrology in solar systems or photovoltaic systems, we work actually in Saudi Arabia, try to create some reference standards to measure the efficiency and to try to measure the power coming out from each cell inside the panels. But our creations still ongoing, and we still do some international comparison with NIST USA, and we are adopting and we are still improving our systems quite very well, which alhamdulillah, now it's helping and serving the production of the solar cell in Saudi Arabia. As I mentioned before, there are so many manufacturing which producing the solar cell systems. It's around, I think it's around 28 manufacturer of solar cell in all Saudi Arabia. So now our solar cell even been exported outside of Saudi Arabia. Our system in the National Meteorology Institute of Saudi Arabia, maybe I will jump here. Our system now, we have built it inside our laboratory, and it's contained two parts actually. One part for simulating the light coming out from the sun, and we put our reference cell here to try to measure it. Then we take the cells coming out from the manufacturers and we compare it here, and also for the power efficiency, and it's coming from here, and we are using a laser technique for measuring this system. This is the type of the system in Saudi Arabia. Okay, yeah. I will try to conclude. This is my last slide, which will explain the use of the system in our National Meteorology Institute, and we are spectral characterization measurement and electrical characterization measurement. This is what we do in the National Meteorology Institute, and the system been working cooperative together with our King Abdulaziz Research and Technology City. We are building these systems, and hopefully it will be very succeed after the maturing by comparison with other with the NIST from USA. This is what we are looking for now, expecting it will be finished very near, inshallah. Okay, that's my last slide. Thank you very much for your attention.
Thank you very much. Thank you very much, Dr. Ismail, for the presentation and sharing. For the audience, please keep the question first, which will be provided for Q&A after all of the speakers deliver the presentations. Now we continue to the next speaker, Mr. Masahiro Hori, PhD. Hori-san, Hori-sensei, please, time is yours.
Thank you for a kind introduction. My name is Hori of Shizuoka University, Japan. Today's title is Nano Manufacturing for Energy Saving Applications. Especially here, I'll talk about energy saving techniques for cryogenic CMOS technology. First of all, I'd like to thank the organizing committee for having a chance to share my recent work. Yeah, okay, thank you. Sorry. Okay, thank you. Before I'll talk about the main topic. Briefly, let me introduce our Shizuoka University. Shizuoka University is one of the Japanese national university. It's a university with over 10,000 students and over 1,000 faculty and staff members. Shizuoka University is located at the center of, around the center of Japan between Tokyo and Kyoto. Shizuoka University has two campuses. One is the Shizuoka campus in Shizuoka City. The other is the Hamamatsu campus in Hamamatsu City. Shizuoka campus has a faculty of education, science, agriculture, and so on. On the other hand, Hamamatsu campus has a faculty of engineering, informatics, and research institute of electronics. I belong. Shizuoka prefecture has many beautiful sites. For example, Mount Fuji, river, lakes, and Japanese tea field. And also, there are many historical buildings such as castle and temples. Hamamatsu City, I now live, is famous for its industry. So there are many famous companies in Japan. For example, a car and motorcycle company of Suzuki, Yamaha, Honda, and music instruments company, Yamaha, Kawai, and Roland. One of the semiconductor company of Hamamatsu Photonics is famous for its high sensitive photon detector, as shown in this picture. So if you have a chance, please visit our city, Hamamatsu. Finally, let me introduce our research institute. Research Institute of Electronics in Shizuoka University, the building is shown in this picture, was established in honor of Professor Kenjiro Takayanagi. He has for the first time developed the electrical television in 1925, and he got the IEEE milestone. So our research topic is mainly focused on the electronics and photonics. Previous slide, yes. Yes, but I can. Yes, thank you. So let's move on to the main topic. First, in first part, I introduced the scaling merits and the scaling limits of MOS transistor operation. Then I talk about the cryogenic merits of MOS transistor. In second part, I'm talking about our recent work for new cryogenic devices. So let's move on first part. As you may know, one of the breakthroughs in electronics is to develop the solid-state electronic devices. In 1947, Baden Shockley at Bell Laboratory in US has for the first time developed the transistor called point contact transistor, which works on-off electronic switch. As you can see, this point contact transistor is quite large size. However, this is a very important step for developing the MOS transistor, MOS FET, metal oxide field effect transistor. Now the transistor size is below 10 nanometer, and many transistors are integrated in one chip, as shown in this figure, and which is called as integrated circuit, IC chip. So this transistor demonstration is trigger of the information age. Yeah, I briefly introduced the scaling merits of MOS transistor. This figure again shows the structure of MOS transistor. There are 3 terminals, gate, source, and drain. When a voltage is applied to the gate, electron current flow between source and drain, or turn-on switch. This transistor operation is often compared to the water flow. Namely, gate corresponds to the water valve. Electron current flow corresponds to the water flow. If you want to fill the cup with water in short time, you may think scaling down is a good idea. Actually, scaling of transistor improves the performance. Therefore, for example, signal transfer speed becomes faster and power consumption becomes lower. Therefore, so far, the transistor size has continuously been reduced. And now the size is 10 nanometer. This trend of scaling is known as the Moore's law. Moore was an Intel corporation in US. However, the scaling merit has already lost in the middle of 2000. This graph shows the number of transistors per chip, clock speed, and power consumption as a function year. As you can see, the number of transistors monotonically increases with decreasing the transistor size, as I showed in previous slide, which follows the Moore's law. However, the power consumption exceeds the limitation. Therefore, it's hard to increase the clock speed. If you want to increase the clock speed, more and more power is required, which leads to the thermal breakdown of IC chip. Therefore, downscaling failed around the middle of 2000. It's referred to as power wall. To make matters worse, electricity demands of ICT recently accelerates. Here, ICT is the information and communication technology. This graph shows the energy forecast of power consumption. Blue, red, yellow, and green shows the power consumption of network, production by ICT, consumer device, and data centers. As you can see, the power consumption rapidly increases around 2020. Right side graph shows the total global electricity demand in 2020. It's expected to be 40,000 terawatt hour, which includes the motor, lighting, heat exchanger, and so on. The important point is that ICT, electricity used by ICT could exceed 20% of global total by 2030. Therefore, energy efficient computing is required. In other words, high performance but low power consumption device is required. Therefore, so far, various structure, various material, and various computing schemes are proposed for the MOS transistor. For example, 3D structure such as pin-type transistor was proposed, and gate oxide material, high-K material was proposed. However, transistor performance is limited as long as the transistor operates at room temperature. So another solution is required. One of the solutions is to operate the MOS transistor at low temperature. So here, I briefly introduce the cryogenic merits of MOS transistor operation. This graph shows the current as a function of gate voltage for a MOS transistor. Red and blue show the room temperature and low temperature operation. As you can see, as compared with the room temperature operation, low temperature characteristics has steeper switching, reduced off-leakage current, and higher on current. These advantages lead to the lower dynamic power consumption and lower static power consumption and higher speed. Therefore, one of the solutions is to operate most transistor at low temperature. In addition, interconnect resistance or wiring metal resistance decreases with decreasing temperature. And also, thermal conductivity or heater dissipation enhances with decreasing temperature. These are also advantages for MOS circuit operation at low temperature. Therefore, so far, low temperature MOS operation has been investigated. In 1977, low temperature N-channel MOS transistor operation was investigated by IBM in US, and CMOS and CMOS processor were also investigated. Here, in 1986, discovery of high temperature superconductivity also accelerates this research field because of the proposal of combination of superconductivity material and CMOS circuit. And also, special issue paper has been published, and many special symposiums were held in 1980s. However, after 1990s, low temperature MOS research stagnated. I believe this may be simply because research on new device material and new device structure progressed. However, recently, at the end of 2010, the rapid demand for ICT and quantum computing again accelerates this research field. Right side figure shows the conceptual figure, application of cool CMOS technology. Applications are, for example, high performance computing, deep space electronics, and quantum computing field. Especially in quantum computing, CMOS circuit is installed in the refrigerator in order to control the quantum bit, qubit, at 4 Kelvin. So in 1980s, 4 Kelvin CMOS modeling was proposed, and after that, many papers have been published. Recently, hot topic is energy efficient computing at cryogenic temperature. One of the examples is shown here. This is an estimation of energy efficiency. Vertical axis shows the power consumption, horizontal axis shows the temperature. As you can see, green plot, CPU power decreases with decreasing temperature. Cooling power, blue plot, or refrigerator power increases, but around 100 decreases. So total power, including CPU and cooling power, decreases with decreasing temperature. Therefore, one of the solutions is to operate CMOS circuit at low temperature. Finally, in the first part of my talk, I'll talking about our target. Our target is next cryogenic device to develop next cryogenic device. According to the international roadmap for device and systems, IRDS, there are 3 strategies, 3 approaches: more than more, and beyond CMOS. More is the approach for just scaling down, follows the Moore's law. More than more is the approach for integration of sensor and MEMS in one chip with CMOS circuit. Beyond CMOS is the approach for developing new emerging research device. Here, emerging research device is long-term challenges using the spintronics, topological insulators, and exciton condensation, and so on. Here, we now focus on the exciton condensation. Exciton is a strongly bounded electron-hole pair electron is negatively charged, hole is positive charge. This is because Keystone condensation is expected to show the superfluidity. Superfluidity is like superconductivity at low temperature. So our final goal is to develop the ultimate low power consumption devices using Keystone condensation at low temperature. Right side figure shows the summary of our target, temperature as a function of yield. More approach, the room temperature and cryogenic temperature operations were reported. On the other hand, for the beyond CMOS, room temperature transistor operations were often reported. Our target is here, namely beyond CMOS approach at low temperature. So let's move on second topic. Here, I briefly introduce our recent work. Formation of electron hole system in silicon MOS transistor for new device, new cryogenic devices. Here, I briefly overview our research. Formation of electron hole system in silicon MOS transistor. This figure shows the conventional MOS transistor structure, gate, source, and drain. We, for the first time, demonstrated electron and hole coexist at the silicon MOS interfaces. This blue shows the hole layer. This red shows the electron layer. By observing the recombination event, we found that the electron hole layer distance is 6 nanometers, which is a Bohr radius of silicon. We expect to observe, we want to observe the Keystone condensation and superfluidity by using this system. But today, I'll show you the primitive data. So I'll show you the detail of our research. Here, I explain the electron hole system in semiconductors. Electron hole system in semiconductors form various phases, such as Keystone gas, plasma, rigid, depending on the temperature and density due to the electron hole Coulomb interaction. This electron hole system has been studied from the viewpoint of the fundamental many body physics. Recently, Keystone condensation phase, such as Bose-Einstein condensation, is actively studied because of the development of technique and physics of electron hole bilayer system. As I said in previous slide, our final goal is to observe this Keystone condensation at the silicon MOS transistor interfaces. Here, I briefly introduce the pioneer work of Keystone Bose-Einstein condensation and its application to electronic devices. In 1960s, Keystone condensation was theoretically predicted, and the possibility of superfluidity was also proposed. Therefore, after 1990s, electron hole bilayer system was investigated in compound semiconductors and recently in two-dimensional materials such as graphene, as shown in this figure. Stimulated by these studies, recently, application to electronic devices also proposed, such as bilayer excited spin field effect transistor BISFET. The conceptual figure is shown here. However, there is no research aiming at Keystone condensation in silicon, the most important material in electronics. For the observation of Keystone condensation, the formation of dipole Keystone is required. However, there is no technique. So in this study, we propose the technique for the formation of electron hole bilayer system at silicon MOS transistors, as shown in this figure. And we demonstrate the closely packed electron hole bi-layer system. Yeah, I briefly introduce the key method for the formation. In conventional MOS transistor, there are two types of transistor. One is a P-channel MOS transistor. The other is an N-channel MOS transistor. P-channel MOS transistor, positive charge or hole flow between source and drain. On the other hand, in P-channel MOS transistor, negative charge, N-channel MOS transistor, negative charge or electron flow between source and drain. Therefore, only either electron or hole can flow. In other words, it's impossible to coexist electron and hole at the MOS transistor interface at the same time by using conventional operation. So we propose a new method. By controlling the gate voltage precisely, we first accumulate the positive charge hole and then introduce a negative charge electron, resulting in the electron hole coexistence. Next part. Next, please. Okay, thank you. Thank you. I'm sorry. So I'll show you the detail of the formation method. Left side figure shows the setup. Right side figure shows the energy band diagram. When a negative bias is applied to the MOS gate, positive charge or hole accumulated at the interface. We call this stage pulse set stage. Then we apply the voltage change with the gate to the gate, and electrons flow into the channel and resulting in the electron hole coexistence. We call this stage pulse on stage. This electron hole coexistence persists until the recombination event occurs. The important point is that this recombination lifetime is sufficiently longer than the keystone formation on the order of 1 microsecond. In this study, we confirm the electron hole coexistence by measuring the recombination current. Yeah, I briefly show you the expected characteristics. Left side figure shows the energy band diagram as I showed in previous slide. First, negative bias is applied to the gate and positive charge is accumulated at the interface. When this voltage is negatively increases, the hole density, positive charge density increases with decreasing this voltage. Upper side figure shows the energy band diagram. Blue ball shows the hole density. Then rapid gate voltage change is applied. If this amplitude of voltage is a constant value, the electron density is expected to be constant, as shown in this figure. Red ball shows the electron density. So we expect that the recombined electron hole density is expected to be linearly increases, then saturate, as shown in this figure. This is because the electron hole recombined density is determined by the hole density in this region, which is smaller than the electron density. On the other hand, this saturation region, recombined density is determined by the electron density because of the which is smaller than the hole density. Therefore, recombination current linearly increases, then saturate, as shown in this figure. Let me show you the experimental data. Left side figure shows the energy band diagram as we showed in previous slide, and right side shows the experimental data. As we expected, the recombination current increases, then saturate. From this linear region, we concluded that the hole density is well controlled by the voltage. And here, in this experimental, we fix the amplitude of voltage. We then change the amplitude of voltage. As we expected, the recombination current increases with increasing the amplitude of voltage, and we replotted this data as a function of amplitude of voltage. We concluded that electron density also can be well controlled by the pulse voltage, and we found that electrons are capacitively coupled to the gate. We obtained these two data. We then analyze the capacitance, and we estimate the electron hole layer distance. From the slope of this region, we can estimate the capacitance, get to hole layer capacitance, and get to electron layer capacitance. As you can see, the capacitance values are little different. So we can express the gate to electron layer capacitance using this equation, using the gate to hole layer capacitance and additional capacitance. Here, D is the electron hole layer distance. We can estimate the D and found that the value is about 6 nanometers. This value is very close to the Eckstone Bohr radius in silicon of 5 nanometers. Therefore, we concluded that closely packed electron hole barrier system was successfully formed by using this system. Finally, I'll show you the time domain measurement of the recombination current. Left side figure shows the setup for the real-time monitoring of the recombination current. Right side figure shows the experimental data. I'll skip the detail, but we observed the two recombination events. One is a fast recombination event, the other is a slow recombination event. From the recombination lifetime, we found that these are the high density plasma and Eckstone. Namely, this data strongly suggests that the formation of Eckstone. As I said in previous slide, Eckstone is important for observing the Eckstone condensation or superfluidity. But this is a primitive data, so I needed to analyze more data. So finally, I'll summarize my talk. In first part, I introduced the cryogenic electronics. Low temperature MOS operation improves the performance. And at low temperature, total system power is estimated to reduce even in the cooling power. In second part, I briefly introduce our recent work for new cryogenic devices. Finally, I would like to thank our staff member of Nano Device Group in Shizuoka University and member of Ono and Hori Laboratory. If you are interested in our laboratory, please visit our website. Thank you very much.
Okay, thank you very much, Hori Sensei. Very interesting, and I think some of question for the online. Please write down your question in the chat. We continue connecting to Japan for the third speakers. Mr. Tatsuyani Kuni, are you still connecting?
Yes, I'm still connecting.
Okay, yes, please, now time is yours.
Thank you very much. And then I asked staff to change my presentation pages. So may I ask again? on the screen. Thank you. By the way, can you hear me?
Yes, clear.
Okay, thank you. So would you move to the next page? Would be a title page. Yes, the title of my presentation is that outline of activities aligned with Japanese strategy on vehicles toward carbon neutrality. So again, my name is Tetsuya Nikuni, and I from NTSL Nowtech, which is organization of Ministry for Land, Infrastructure, and Transport. So would you move to the next one? So with my presentation, I would start with statistics of Japanese situation of carbon dioxide emission. So in left hand of this page show the total amount of carbon dioxide emission in year 2022, which was around 1 billion tons. And then, so as a transport here, thank you very much. Approximately 19% is there, yes. And then in right hand, I show the kind of portions. Yes, would you move to right hand? Yes. And then roughly half of the percentage would come from private passenger cars. Yes. And then another one is from trucks and commercial trucks. So our subject is to reduce the carbon dioxide emission due to these cars. Yes, would you move to the next page? Again, this is the statistics to show the trend of carbon dioxide emissions. And then in Japan, after 2001, the trend is going down. Yes, it is quite a good trend, but we have to keep that trend. Yes. And then next one would be a quote from the former minister, prime minister's speech in the past. So in 2020, the goal is to reduce overall greenhouse gas emissions to 0 by 2050, meaning a carbon neutral, decarbonized society in 2050. And then green growth strategy for carbon neutrality in 2050 was stated in 2021. And then I will explain it in detail in the next page. Yes, then also we had a kind of speech by the former prime minister here at COP26. With an aim to realizing that a future where vehicles, the world's essentials, will become zero emission. Japan will take advantage of all the available options of technologies. Yes, including electrified vehicles and also e-fuels or something like that, synthetic fuels. Yes, and then green growth strategy for carbon neutrality in 2050. And then concretely for passenger vehicles here, electrified vehicles will account for 100% of new vehicle sales by 2035. So then here, electrified vehicles include electric vehicles and fuel cell vehicles plug-in hybrid vehicle and also hybrid electric vehicles. And then for commercial vehicles, which is heavy-duty vehicles over 8 tons, an advanced introduction of 5,000 vehicles in the 2020s. And then setting a target for 2040 electrified vehicle penetration by 2030. And then bottom one is commercial vehicle, but under 8 tons, which is a very small trucks. And then electrified vehicle will account for 20 to 30% of new vehicles sales by 2030. And then electrified vehicle and also decarbonized fuel vehicles will account for 100% by 2040. These are targets. And then also a target was set also for transport companies, include logistics companies, so like these. Yes, then move to the next one. So what we can do is, so we have kind of a three pillar approach like this. And then left side, establishment of fuel efficiency standards here. Then fuel efficiency standards for passenger cars. So in 2020, the 2030 standards were established. And then for heavy duty vehicles, so in 2006, the world's first fuel efficiency standards for heavy duty vehicles were set. And then next one would be tax incentives and subsidies. So above side is tax incentives. So exemption for next generation vehicles such as electric vehicles. And then below side would be subsidies. The subsidies provided for the introduction of vehicles with high environmental performance. And then right hand show the international harmonization of vehicle regulation. It is quite important issue for us. Then FCVs and electric vehicles, adoption of the relevant technical requirements at the UN regulations. And also ALCA, which is automotive life cycle assessment. It is also important activity. So I will explain this in a later part of this presentation. So again, these are related to the United Nations activity. Thank you very much. Then next would be outline of activities in Japan for carbon neutrality. Yes, and then move to the next page. Here, establishment of the Carbon Neutrality Center, newly established here. Then, of course, as I explained, we have a target. So to meet the target, we established the Carbon Neutrality Center newly, and then many stakeholders are involved in this center, and also it is under the JASIC organization here. Yes. And then next one would be a diagram to show the structure behind this. And then, of course, for World Forum for harmonization of vehicle regulation under the United Nations, of course, a proper representative from Japan is MRIT, the Ministry for Land Infrastructure and Transport. And then behind this, we have a carbon neutrality center here. Yes. And then another ministry. So left hand, which is Ministry for Industry, and also a Ministry of Environment are involved in this activity. And also ourselves as a NTSL also involved in, and from industry, automotive industry, and car parts manufacturers are also involved in this center. And also we have collaboration with industrial standardization activities and also relevant governmental measures here. So with the center, we create one voice as Japan to the United Nations. And then after this part, I would explain the activity of Carbon Neutrality Center here. And then Carbon Neutrality Center has reviewed the status of relevant regulations, especially for electrification or battery. And then also we focus on next generation fuels. But today, I will explain the status of relevant regulation regarding electrification, especially. Yes, so now we have table here to show United Nations regulation and also global technical regulation related to electrification of vehicles. And then move to the next one. Yes, then regulations related to safety of electrified vehicles. So United Nations regulations 100 and 136 and GTR 20 are related to safety aspect of electrified vehicles. Yes, and then so below as a vehicle level safety required to prevent to protect passengers from electric shock in general. And also these regulations specify the requirement for battery safety as well to avoid maybe from the vibration or a heat shock or something like that. So batteries should be protected against these kind of stresses in general. And then below one is a kind of a unique one, but so in general, electrified vehicle has a low level of sound noise. So might be dangerous for the people around the vehicle. So especially for disabled people. So it has kind of a regulation to make a sound, specific sound to appeal them that the vehicle is approaching to them. Yes, these are related to a safety issue. And then second one will be safety for fuel cell vehicles. And also it has a vehicle level safety and also hydrogen tanks should be, yes, managed, protected, and also valves. Sorry, I don't specify the number of regulation, but yes, the UNR 134, yes, thank you very much. And 146 and the GTR 13 are related to these. Thank you. And then next one would be, yes, important thing, which is durability of onboard batteries. And then GTR 22 defines the requirement for batteries. Yes, battery electric vehicles and plug-in hybrid electric vehicles. Yes, Then in the center, we have a table to show the requirement as a performance, so 80% of capacity should be kept for 5 years and 100,000 kilometers, something like that. Yes, also important. And then I think it be last one. And then yes, related to fuel consumption and power output power of electrified vehicles. And then these are defined as UN Regulation 154 or GTR 15. And also GTR 21 is describing about the requirement for the test method of system power of electrified vehicles in general. So UNR 156 is so the name is maybe famous as a WLTC mode. Yes. Then these are brief explanation about the status of United Nations regulations related to electrified vehicles. And then move to the next one. Yes, then as a Carbon Neutrality Center, we held an international symposium in last September to invite key people in international regulation area. So we invited the chair of GRPE of UNECE WB29. And then also we invited the key person from European Commission Joint Research Center, and also from the US EPA, and also China, Qatar. And then also we invite Japanese government, and then from JAMA industry. Yes. And then we also have a panel discussion to discuss about how we can deal with the rule making in general as an international activity. We discussed about this. Yes. Thank you. And then next one would be automotive life cycle assessment under GRPE UNECE WP29. Yes, this activity is related to the development of methodology of carbon dioxide emission through entire life of vehicle in general. And then this group was established in 2022 under UN WP29. And then this group led by Japan NTSL, which is me, and also a Korean delegate. And then this work is still ongoing, but not for regulation yet. We are focusing on the development of national guidance of the methodology to calculate carbon dioxide emission entire life of vehicle. Yes, this picture was a first session. Yes, this is a schedule of the group. And then in the center or a little bit right side, yes, we are now in, yes, around this. And then we have a kind of a first, yes, thank you, target, which is March. So the end of March, next GRPE will be held. So our so we are working to develop the consolidate a document to be submitted to our next GRPE. Yes, then next one will be later. Would you come back again for the schedule page? Yes. Then next target would be around October this year. Also, next GRPE will be held. So our target is to submit a formal document to the session. Yes, and then move to the next one. Yes, this is a working structure. And then you may aware that so life cycle assessment, we need many kind of knowledges. So it is quite difficult to organize as one group. So we set several small groups, like small groups like these. So in left side, yes, start with material acquisition here. This is responsible for a subgroup 2, and then this group is led by Japan. Thank you. And then next one would be a production phase, production for parts and production for vehicle. And then this group is led by Korea and Oika and Crepa. And then next one will be use phase, use stage. And then this group is led by European Commission, JLC. And then last one would be end of life of vehicle. And then this group is led by China and Japan. And also we have a horizontal group to take care of fuel and energy here. Yes, which is SG6. And then this group is led by Japan and Avere. And also we have drafting group. And then above side is administrative group to invite leaders from SG leaders. So this is a working structure of ALCA, informal working group. Yes, and then next one would be level concept we are considering now. Then level concept is to describe the level of usage of primary data. Primary data is actual measured data by a company or something like that. And then in this concept, higher level has a higher accuracy, and then the situation will use a lot of primary data. So we are considering to introduce this level concept for our draft. Yes. So yes, the next one will be introduction of our organization's activities for carbon neutrality. Yes, and then next one will be next generation heavy duty vehicles development and commercialization project. Yes, then the purpose is to reduce carbon dioxide emission, especially from the heavy duty vehicles area. And then we have two major issues. One is electrification of heavy duty powertrain. Yes. And then another one is carbon neutrality of fuels. And then would you move to the yes, bottom of this page. So I explained a little bit further about both issues. So one, electrification of heavy duty powertrain. So especially we are developing technology related to cooperative regenerative braking system for heavy duty vehicles. And also we are working on heavy duty fuel cell vehicles like this. Yes. And then second one will be carbon neutrality fuels. And then we have several researches on fuels, especially for high efficiency combustion of hydrogen. and also including synthetic fuel combustions. Yes, and then this, would you move, come back? Yeah, yes, thank you. And then this project was administrated by MLIT, and then our organization, NTSL, is responsible for the as the center of this project. And then we collaborate with academia people and also industry people. Yes, then move to the next page. This page describes the history of the next generation heavy duty vehicles project. So actually, yes, this project was started in 2002. Yes, and then in first stage, we are focusing on the prevention of air pollution. So the main technical items are combustion engines, like super clean diesel engines or something like that. So in a later part of the history, we are focusing on carbon neutrality more. And then last, yes, bottom one is the current status here. Thank you. And then next page would be subject conducted under the current status. Then, so third one of the lines, so cooperative regenerative braking system. So we are working with industry, ISUZU, and also several university. So if you look at the top, yes, we have a wireless charging system project together with Tokyo University of Science. And then below side related to internal combustion engines. And then we have several projects with several universities. Yes, this is the outline of our project. Yes, then move to, yes, yeah, this is, I guess, the last page of this presentation. Then I briefly introduced the Japanese strategy and also including some targets for carbon neutrality. And then Carbon Neutrality Center was established. And then I explained the status of the Carbon Neutrality Center. And also I explained about the status of ALCA, Informal Working Group, and WP29. And then in the last part, I introduced the project of next generation heavy duty vehicles development. So thank you very much. That is all.
Okay, thank you very much. Once again, give the big applause for all of the speakers today. Okay, thank you. Because we delay starting our presentation, so we still give the Q&A session until 11:30. Now we open the question from the offline who are attending in this room. Then we will collect the question from the virtual participant. Please, if you want to make the questions. Okay, who wants here? Cannot see, sorry.
Good morning, everyone. Thank you so much for this opportunity. My name is Yedid from Institut Teknologi 10 November ITS Surabaya. The question is actually all of the keynote speaker, but especially to Professor Tetsuya Nikuni, but actually it's all for all of the keynote speaker. So since the development of the carbon neutrality is so massive, it's a huge focus of the world right now. So this is also in Japan. I see the future of the vehicle industries in Japan to help the environments getting better, because the CO2 or the carbon is quite high, and the world is want to reduce it right now and to make the environment better. The question is how to encourage all of us, in this building or all of the world to follow this success story of the Japan to decreasing or to neutrality the carbon. So that's the question. Thank you so much.
Okay, thank you, Mr. Siddiq from ITS. This question is for all of the speaker. Only one question from this session. I see two participants who will question in this room. Please, committee, give the mic. Yes.
Thank you very much. I would like to ask for Dr. Dikuni. I am Agusta from Research Center for Sustainable Production System and Life Cycle Assessment. So I would like to ask about how do you think the comparison of LCA between because we know that there are two established technology these days to replace the internal combustion vehicle. So how do you think the comparison between the hydrogen fuel cell vehicle versus EV, electric vehicle, in terms of the LCA results? So because I think there is so complicated to compare these two technologies. Thank you very much.
Okay, thank you very much. Now we collect two questions, and we want to hear the answer from the offline participants, for the offline speaker and online. I think the questions directly asked to the Niku Nisang, and then
Yes.
after you explain the answer of the question, we will add by the other speakers here. Okay, please, Niku Nisang.
Yes, thank you very much. And also thank you very much for your questions. And then I guess first one would be like, from my interpretation, I was asked like, so how we can deal with the situation as an international activity or something like that. So from my view, as I said during my presentation, Japan is involved in the establishment of harmonized regulation, internationally harmonized regulation. And then I think it is something good way forward, because with the regulation, we are able to compare the performance between several type of powertrains. So I think this is quite a good way forward, I believe, at least. And also the second question was related to LCA. And then, so it is really difficult to say which one is better or not, because it is related to a kind of a regional issue. So then to come back to my presentation, so the group as LCA is just working on a kind of established kind to develop the methodology itself, but the group will not specify the specific value or data to be used. So I hope this harmonized methodology will be used for each nation to evaluate their technologies by their own. So this is something my message, but I think it is not a direct answer to the question. So I'm very sorry, but this is my opinion. Thank you.
Okay, thank you, Nikuni-san. Now we want to hear from Hori Sensei that have present about the supporting technology in regarding with the carbon neutrality as well. Please, Hori Sensei, maybe you want to explain about the question.
About the first question?
Yeah, yes, the first question. Yes.
I think Japan attends international roadmap for semiconductor, and I think it's very important for reducing the power consumption. So it's very encouraging for me. So sorry.
Yeah, maybe when you are conducting the research, you consider all of the aspect from the regulation, from the community, how to harmonize.
Yes. So international roadmap is regulates the device fabrication process or something like that. According to that.
Okay, thank you. And now I want to hear the response from Dr. Ismail regarding to the new technology or the effort to reduce the emissions, like Japan, which can make the roadmap or the harmonization for all of the stakeholders. How about in Saudi Arabia? In carbon neutralization.
Okay. In my presentation on the last few slides, I present a case study about renewable energy. And if you see in the map of Saudi Arabia, there are so many farms for photovoltaic renewable energy. Each one of them participates on the CO2 emissions reductions, actually. And for Sudair, one of them, which is Sudair, you can see the number of reductions from it's nearly 2.9 million tons of emissions per year. This is just one farm from the renewable energy and solar cell systems in Saudi Arabia. And if you add it to all the other in the country, so you will see how much it's participating on the reductions. And the vision 2030 of Saudi Arabia, we are planning to implant so many number of trees because we are a desert countries, and there are actually a goal to implant a huge number in the kingdom, and also the Ministry of Agriculture and the Ministry of Economy, and also the Center of whether are working all and cooperating all together to reserve the plant, which is very shorted in Saudi Arabia. So there are so much effort to reserve it from all the kind which will destroy the greenie in Saudi Arabia.
Oh, wonderful! Yeah, I think this is the real plan, yeah, not synthetic plan like that.
Yes, it's real plan, and it's ongoing actually. And if you visit the kingdom, you will see so many places. I already started about that, and we grow a plant actually related to our land, not exported from outside. So that's live in the same weather in Saudi Arabia.
Okay. Yes, very interesting. Okay, ladies and gentlemen, before we open the next question from the offline participant, I would like to see the question from the virtual participants. Is there the... Okay, thank you. This is the question for Dr. Ismail. How does this from Suherlan? Yes, from BRIN. How does metrology contribute to the energy and manufacturing sector in Saudi Arabia? And what are the key challenges in ensuring measurement accuracy in these industries? And number two, how does SASO ensure compliance with renewable energy standard, and what impact do the standards have on the adoptions of solar and wind energy in Saudi Arabia?
Regarding the first questions, how does metrology contribute to the energy and manufacturing sectors? As I show in our National Metrology Institute Center, we developed a full system for solar cells. And these systems actually working together with the Research and Technology City of King Abdulaziz, and we are cooperating together because they already have like a manufacturer of solar systems and solar cells, and we are all cooperate together between NMCC and the KAUST, which is the King Abdulaziz City for Technology. On this matter, we are doing some kind of research between these two laboratories, and we achieve good results in this matter. This is one way. The other way, also SASO working with Ministry of Energy and creating a working group with the Ministry of Energy, and most of this group was leading by the Ministry of Energy to focus on the standardization need for the energy sectors. This is, I think, I hope.
Okay, thank you. I'm sorry, one question left because I didn't see from Mr. JJ. How does SASO collaborate with international standard organization to ensure the global trade?
Okay, yes. Actually, we are already a member of so many international organizations for standardizations, such as ISO, and last year or the year before, I forget, our director was on the board of this ISO. And most of the standards coming from this international organization been adopted to be as local standards. And also we are reviewing many of these standards, and we adding some notifications to these standards.
Okay, maybe for the next, Indonesia can make the collaboration about the standard, because some of the participants came from Research Center for Testing and Standard. Yeah. And the next question from Benny Lohena Pesi. This is the researcher from Research Center of Testing Technology and Standard as well. In your slide presentation, it is very clearly about MSTQ, measurement standard testing and quality. But I want to clarify, include number one, could you please explore more about correlation of standards, metrology, and calibrations? Okay, then number two, in your presentation, you talk about development of SASO standards. The question is, development of SASO standard you start from research center in SASO or research standard, come from industry and other institution in Saudi Arabia. Maybe about the foreign standard as well. How do you adopt it? And number three, it is possible that we from Research Center of Testing Technology, BRIN in Indonesia, will continue to join research with SASO. Thank you.
Okay, I will start maybe the
Yes.
third one. Actually, I hope that, and I believe we can make a good cooperation, and probably in the near future we can sign MOU between SASO and BRIN, which will make our job it's much easier, inshallah, in the futures. Regarding the questions that correlations between standards and methodology and calibrations. As I mentioned, there are so many standards need several type of measurements and several type of way of measurements which need to be adopted in some type of these standards. So sometimes our teams in the National Meteorology Institute are participating in the working group of these standards and participating in this group to create a new or to adopt a new standards coming from other international standards. The next question is
collaboration. You have explained about we can make the MOU in the near future. Okay, thank you very much for the question from the Zoom session. Now we go back to this room. If you want to make the question, please raise your hands. Okay, one for there. Again, in the middle or in the left side. Okay, one question, please.
Thank you very much. Thank you very much for your insightful presentation. Actually, my name is Hima from BRIN. My question is directed to Hori Sensei. From your presentation, you propose a technology to continue decreasing the device size, semiconductor device size, to decrease the power consumption. Instead of using electron flow, you use what is called condensed exciton actually. Based on your research, could you briefly explain how to confirm that your device really work with condensed exciton principle? Because nowadays there is no meter or instrumentation to measure the current with condensed exciton actually. I don't know. Please explain briefly. And the second one, have you compared the power consumption with your proposed device with the electron-based device at the same technology size? Thank you.
Thank you for your question. For the second question, I don't know the detailed power, but according to the literature, atto power, in one device. Sorry, could you ask me a question? First question.
Compare between electron-based device, electron-based.
Electron?
Yes. Conventional MOSFET device.
Yes.
Compare with your proposed device with exciton, condensed exciton.
Yes.
What is the comparison power consumption?
Sorry, power consumption. Sorry, as I said, power consumption will be reduced at zero. Sorry, I don't know the conventional MOSFET transistor power, but is expected to be reduced.
Okay.
Sorry.
Or maybe you have other technique to confirm the power consumptions for the cross-check analysis in other technique.
Sorry, our device is not has not been completed. So next issue.
Yeah, okay. I think very interesting because the cryogenic activity is very difficult because some of the materials will could change the characteristic of the material itself, or sometimes maybe it will be cracked, something like that. But in the effort you reduce the temperature, you can reduce the power consumption as well. Okay. How about the answer, Mr. Hima? It's okay? Or we will confirm again?
Maybe we will discuss more, maybe
Okay.
technically.
Yes, yes.
Thank you.
Okay. Yes, thank you very much. Okay, the next questions. Can I see others will make the question here. Okay, maybe from the virtual participants. This is the questions, especially for Mr. Masahiro Hori from JJ. What are the key benefits of using cryogenic CMOS technology in energy-saving applications?
I think power consumption decrease is a key benefit for.
Yes, maybe you have the benefit compared with other technology that utilizing the cryogenic CMOS.
Yes, especially in the data center, is more and more power is required. So this device may be applied to such a data center or high performance computing, not to mobile phone, not to PC.
Oh yes,
high performance computing is
Okay. Is it only comply with the nano materials, or generally it can apply for all of the activity in manufacturing system? What's your opinion?
Of course, yes. We continue to join.
Yes.
Yes, of course, yes, of course.
Yes. This is the next question from Benny Lohena Pesi, still from Research Center of Testing Technology and Standard. Is it possible that we from Research Center of Testing Technology, BRIN, will continue to join of electric and electrical research with Shizuoka University, Japan?
Yes, of course, thank you.
Okay, thank you very much. Not only for Research Center of Testing Technology and Standard, in my research center, process and manufacturing technology as well. And I think for others research centers that attend this international conference. Okay, next for Nikuni-san, this is the question from Mr. Benny. How effective research organization influencing the regulator in Japan, in the institutions, government in developing strategies to achieve carbon neutrality? Hello, Nikuni-san.
Yes.
Yes, yes.
Thank you very much. So, regarding regulation, which is something you have to follow. So, setting regulation will be has to be fair to test the vehicle. So, so our organization is working on them to accumulate data from actual vehicle to make regulations fair. So then I think I believe to have the fair regulation, then I think this will encourage the kind of healthy condition of the market, because people can compare vehicles with a fair methodology. So I think this is something we expect as a contribution to the government, or maybe set up the regulation. I hope this would be the answer to the question.
Maybe the research institutions include the university as well. How do you think about the participant of what kind of research institution, from the government or private research institutions?
I think to develop fair regulation, of course, enough knowledge about the technology will be necessary. So we have kind of a collaboration with academia to accumulate the data as much as possible. So we have to set a regulation based on correct technical evidences. To gather such kind of technical evidences, the cooperation with academia area will be definitely needed.
Oh, okay. Thank you very much for the explanation. I think I believe that still more questions from the participant here in this room and the virtual participants. But time now nearly 11:30. Thank you very much for all of the speakers, and let's give the big applause again for all of the speakers and all of the participants. And finally, I think this session is finished, and I'm sorry for the mistake or inconvenience during the presentations and discussions in plenary session 3. I want to, for the next, return back to MC. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Please give the warmest applause for this incredible session. I can see your excitement because we have a lot of questions, and of course during the break, if you want, you can continue discuss with them. But this session has to complete, and thank you so much. And as our expression of gratitude, we would like to deliver some souvenirs from BRIN. As the host of ICSEEA 2025, I would like to invite Professor Chu Supriyadi Ahlinandar as the head of Energy and Manufacture Research Organization BRIN to deliver the souvenirs to our speakers. Please, Pak. Yes. Thank you very much once again for preparing the presentation, delivering the presentation, sharing with us all the expertise, the experience, and then even welcoming us to have the collaboration. I heard some researchers in BRIN would like to have collaboration research in university. Thank you so much, Dr. Ismail Al-Faleh. There are some audience also who want to have research together with SASO in Saudi Arabia. Sounds very interesting. And since Dr. Nikuni is not here but online, but to represent him, to represent him, we would like to invite Mr. Nova to help us as representing Dr. Nikuni, because Mr. Nova is Dr. Nikuni's colleague, and he will kindly deliver the souvenir to Dr. Nikuni. So, Dr. Nikuni, don't worry, you will also get the souvenirs. Okay. To Dr. Nikuni, thank you so much for sharing with us from Japan, and maybe it's already lunchtime over there, already past actually lunchtime. Thank you so much, and please contact Mr. Noba to help you to get the souvenirs from us. Again, thank you so much, Mr. Noba. Onegai shimasu. Thank you so much. Okay, we can have group photo after this. And the moderator. Once again, a big applause to the moderator, Dr. Hans Saputra, who lead the discussion very interestingly. And can you please have a group photo together? A very good chance for all of us here to be together. And I think it's really good also for the audience to have very diverse information and insight. Okay. Once again, ladies and gentlemen, please give the warmest applause for this session. Okay. Okay, so let's continue with the next session. Next session is the industrial talk. So the speakers for this session are from companies. We will have two speakers. First is Tim Lehman from Par Instrument USA. And next speaker is Mr. Rahmat Hidayat from PT Hioki Electric Indonesia. And this session will be chaired by our moderator, Dr. Tata Sutardi. Thus, I would like to invite all of them. Please welcome Dr. Tata Sutardi, Tim Lehman, and Mr. Rahmat Hidayat. Please come to the stage.
Can I start? Good afternoon, ladies and gentlemen. It is an honor for me to be able to be here to moderate our discussion today. And of course, I also feel happy because our speakers today are already here, and I'm pretty sure you will have quite a lot of questions, yeah, for them, because what they're going to say to you will be something familiar with your activities in research. Yeah. So I'm going to introduce the speaker before they give their presentation by one. The first speaker is Mr. Timothy Lehman. Good afternoon. Nice to meet you, Mr. Tim. Mr. Timothy is the president, vice president, yeah, of Par Instrument for Jakarta, yeah, Indonesia and Southeast Asian, yeah, for the whole world. And he spent his study in US, yeah. He will present the activity or the mostly of the products, yeah, that Par produce that I think this product also familiar with many of researchers who come here, yeah. And the second speaker will be Mr. Ahmad, yeah. To be honest, actually he's my old friend. It's been quite a while. I haven't met him. So when I see his picture, I still remember his face. Nice to meet you again, Pak Ahmad, after quite a while. Pak Ahmad is the manager, yeah, marketing manager for the Hayoki, yeah. Yeah, Hyoki. He spent his education in Bandung and in University of Indonesia. Yeah. And he's been in PT Hyoki Electric Indonesia for about 6 years, yeah. Nice to meet you. So before you convey your question, maybe I will let them, the presenter, to present their material, yeah. I will start from Mr. Tim and then Pak Ahmad. After they finish after they complete the presentation, then I will let you to give us opportunity to ask them. Okay, the first opportunity I would like to Mr. Tim to invite you, please, Mr. Tim. Please give applause for them for Mr. Tim.
So I have just a few notes, and I've noticed that in the past few years, even this being this far away is too far, so I'm sorry, but I have to use my glasses. So first, I'd like to start by just saying thank you for all of you for being here. It's a great privilege for me to stand on this stage and address you this morning. I know that I'm keeping you and my colleague, we are keeping you from lunch, so we'll keep our remarks brief and direct, but I also welcome any questions after the presentation. Thank you to the organizing committee. If you have never organized a meeting like this, you don't know how much work goes into all of the little details behind the scenes. And thank you very much for all of your efforts this week. It's been a lovely event and I've really enjoyed being part of it. Also, thank you to all the speakers and presenters from yesterday and this morning. Our MC mentioned just briefly a minute ago, the diversity of presentations has been amazing. To hear about nanometer scale transistors and metrology and standards 10 minutes apart. I'm not sure that there's any other meeting that would allow you that kind of opportunity. So speaking of presentations, my presentation will be a bit different than many of those that were given here this week, in that I won't be focusing on a single area of research. I will be giving a very broad overview of basically the energy economy, and then talk a little bit about some case studies where PAR equipment has been used perhaps to support different research activities across different kinds of research. Why would I do this? Basically, the purpose of my talk is to share with you an overview of a set of tools that may be useful. The products that the company that I work for makes are research tools. When I first started at the company nearly 15 years ago, I had dinner with my family, with my extended family, and one of my relatives asked me, "What do people use with the equipment that you make?" And the answer that I was able to give to that question was anything they like. The equipment is not dedicated for a specific purpose. It basically allows researchers that are working at elevated temperature and pressure, or maybe even cryogenic temperatures, to do their work in an effective and safe way. High pressure, high temperature is inherently dangerous. The company is 125 years old. We've been making this equipment for many, many decades, and safety is the top priority. But the applications for which the equipment can be used are quite varied, and I'd like to show just a few examples of those today. So if I may. tell me where the sensor is so that I can point this properly. Is the sensor in the screen? Oh, okay. Okay, very good. So this is just a brief overview of what the next 15 or 20 minutes will look like. We'll start with some definitions. Please note that my definitions are intended to be very simple and not exhaustive. In fact, you might even disagree with a few of them, but they're really just intended to set a context so that we have a common understanding for some of the things that we'll talk about later. And at the end of those definitions, I'll have a diagram which basically summarizes I'll call it the traditional energy economy. And then I'll add some visuals to that to illustrate basically some of the things that have happened in the last 20 or 30 years as we've started to talk about alternative energy and renewable fuels, something that in the 70s and 80s and even 90s were not as commonly discussed. Then I'll briefly present several case studies, just some examples, one slide apiece that describes and illustrate some of the equipment that have been used to support some of these renewable energy applications in the recent years. And yes. It's okay. Sadly, I know very well what is on each one of the slides. And then I'll talk a little bit about PAR. Now, traditionally, that would be the first slides. I would talk all about the company, but I don't really want to focus so much on the company and on the products. It's really more about the field and the applications and the research that you all and many others are doing. And then finally, I'll share just a single slide about future directions, and we'll just go from there. Thank you very much for your patience. I have quite a few animations, so I just wanted to make sure that I could make this work properly. So first, renewable energy. I think that's a definition that everybody in this room is very familiar with, but energy derived from self-replenishing or renewable resources. You'll see a graphic here in a moment that talks about biomass, hydropower, solar, wind, things like that. Green and sustainable chemistry, again, something that you're all very familiar with. Really what I wanted to emphasize here is the reduction or removal of hazardous substances and the inclusion of recycling in this idea of green or sustainable chemistry. We'll talk a little bit about going from an internal combustion engine to electric vehicles, which has been discussed several times already this week. Talk about plastics recycling, a very hot topic for research now, depolymerization and reuse, injection of CO2 into the plastics value stream, things like that. What does high pressure and high temperature really mean? I have the opportunity to talk to customers regularly, and one person's definition of high pressure and high temperature can be very different from another person's. If people are working in glass laboratory equipment, 2 bar or 5 bar may be very high pressure, whereas a geological researcher may think that 500 bar is just regular, and 700 and 800 and 1,000 bar is high pressure. Similarly with temperature, anything over boiling is high temperature to some, and for others, 1000 C is normal operating temperature. So we'll talk a little bit in some more detail about that. Okay, and the main product that PAR manufactures is a high pressure, high temperature, laboratory scale chemical reactor. Sometimes it's called an autoclave, which is quite different than the device that's used to sterilize medical equipment and other types of laboratory equipment. But generally speaking, it's something between this size and maybe this size that fits in a laboratory, typically made of metal, typically able to withstand multiple atmospheres of pressure, maybe 50 bar, maybe 100 bar, maybe 350 bar, and able to be operated at temperatures to 200, 300, 400, 500, 600 C, depending on the application and the needs of the research. It can be made of many metals. Some research is very corrosive and requires very corrosion-resistant alloys. And we commonly work with probably 10 or 15 different alloys in the manufacturing of this type of equipment, for example. And the equipment can be operated. I'm sorry, I won't touch that again. The equipment can be operated either in a batch or continuous mode. I really promise I won't touch it again. So what you see behind me now is just a general graph or a general diagram of what we might have 50 years ago called the energy economy. On the left, you'll see coal coming from a mine, and what was that used for and what is it used for? Primarily energy generation. So the electricity then is sent to the grid, which is then sent to a variety of places that can either be sent to your home, to a shop, to a factory, and a very specific kind of factory is a refinery. Those are the 4 arrows that I have behind me showing where the electricity might be sent. What else needs to go to a refinery for anything interesting to happen? Well, the oil that we might extract from the ground is sent to the refinery, and then a lot of really amazing things happen. And 40, 50, 60, 70 years ago, the main applications for PAR equipment were in petrochemical and fine chemical research and development. The development of catalysts, most of the processes that happen in a refinery are very high pressure and high temperature, hydrocracking, treating, other types of hydrogen involved applications. And what did those generate? Well, they certainly generated transportation fuels. You'll see a car and a truck. I apologize for those of you that are involved in the maritime industry. I should have put an icon of a boat next to those, but I failed to do that. But my comments apply to that type of transportation fuel just as well as cars and trucks. And also to chemical feedstocks, the building blocks for many of the plastics and other chemicals that we use in our day-to-day lives come from those chemical feedstocks that are often ultimately derived from petrochemicals. So then we see on the far right, what is the output of our homes and our businesses and our factories? There is certainly waste, and municipal waste is one of those outcomes. For many, many years, we just buried it, or we burned it, or we threw it in a ditch or into the ocean or anywhere that it wasn't right next to us. And I think that's been one of the major trends that I've seen in our business in the last 20 years is a lot of research looking at valorization of waste and what can we do with that provides some value and some benefit. So again, I just want to draw a little bit of a contrast between 30, 40, 50 years ago and now in the last 20 or 30 years, the applications that we are supporting our customers' research have changed dramatically, but some of the fundamental things really haven't changed. It's catalyst development, it's basic chemical processes, but now perhaps instead of starting from crude, we might be starting from a post-consumer mixed plastic recycle stream. But some of the research is the same. It's how do we improve those processes, improve the catalysts, improve the utility of those raw materials. Okay, so I'm going to add a few things to this slide, perhaps. Okay, so in the upper left, you can see some wind, biomass, hydropower, and solar. what do we do with those? Well, we bring them into the electric grid just the same as we would by burning coal. What are the kinds of things that we might need to provide equipment to work with? So there's testing requirements. So one of the pieces of equipment that you'll see at the booth just outside this room is an oxygen combustion calorimeter. So traditionally that was used to determine the calorific value of coal. And it's still done every single day in many, many countries around the world. But now as we look at other energy sources, we can do the same type of testing with at least the biomass portion. It's very difficult to determine the calorific value of solar energy by burning it, but for biomass, you can certainly do that. What else might be valuable here? Yesterday, Professor Petrosans from the University of Lorraine in France, she talked about some of her research looking at the processing of wood products for both structural and energy applications. And in one portion of her talk, she talked about impregnating that wood using pressure vacuum cycles. So they would apply vacuum, basically withdraw volatiles from the wood, and then they would apply pressure cycles and push that back into the wood. That's something that a PAR reactor could be used for example, because that's an elevated pressure situation. Also, certainly, these types of fuels can, at least some of them, the biofuels, for example, might be used to generate biodiesel. And we've heard several examples of those processes and how that's an important part of the decarbonization effort. Batteries, that's not something that anyone really talked that much about 30 or 40 years ago. And it's something that you see thousands and thousands of research articles being written every year. Both fixed storage for the grid, so we can send energy to those batteries, and then we can return energy from those batteries to support the grid in times when the wind isn't blowing or the sun isn't shining. It's a very intense focus of research right now. We talk to customers every day who are either trying to develop new batteries or perhaps trying to recycle batteries to reclaim some of the elements in those batteries that are the most expensive, to minimize the amount that needs to be mined in order to reuse and recycle those battery materials.
Mr. Tim, show your time. 5 more minutes.
5 more minutes, okay. So I'll go through these next few a bit more quickly. So we've heard already earlier about alternative fuels, certainly electric vehicle batteries. Those are being developed from some of the same factories that might have been developing other things. And then those are being recycled into the base materials again. Recycling of plastics, we'll talk about that briefly. And then certainly we've heard, for example, from Dr. Fajar about some ionic liquid development using AI. And at the very end of that process, he talked about developing 10, 15,000 different chemicals. There still needs to be physical validation of those ionic liquids for carbon capture and storage, for example. And most of that work is done at some type of elevated temperature and pressure. So perhaps appropriate for a PAR reactor. And then finally, the valorization of municipal waste. It's a very big topic right now. We're hearing from a lot of customers that are looking at how can we take what we're throwing away and recycle it into something that provides energy from that pathway. Okay, so I'll just go through several case studies very quickly here. What you see behind me is a very typical bench scale PAR reactor. This one happens to be 300 milliliters in volume. Basically, it consists of a pressure vessel. This one is rated for use at 200 bar at 350 C, for example. It has valves on the head, which you can use to either introduce or remove gas or liquid samples. It has an agitator. It has a temperature controller. It has a data logger, and that's about it. It can be used for very, very many things, and you'll see some examples here in the next few slides. So this is just one publication just from last year. Catalyst research, regardless of its nature, is one of the most common applications for use with PAR equipment. So in this study, they were working at something like 40 bar and 100 C. Not terribly difficult conditions, but something that you'd need a pressure vessel for. This is just a cross-section through a pretty typical vessel. This is laid on its side. The agitator is on its left, and a cross-section of the vessel is shown on the right. So you can see the impellers there at the far right that would allow the agitation of typically a three-phase mixture. You'd have a liquid solvent, you'd have a powdered catalyst or a solid catalyst, and then often some type of reactive gas, a hydrogen or carbon dioxide or something like that. So this is a case study at one of our, at a laboratory in Potsdam in Germany. They're generating biochar. And again, just one application of using a PAR reactor shown on the right. This is a 20-liter vessel, and they're operating at ambient pressure, but rather high temperature.
One more minute, please.
I'm sorry?
1 more minute.
Okay. So another example of plastics recycling via pyrolysis. It might take me a minute to actually scroll through all of the slides. So we also have continuous flow reactors like this that allow the continuous processing of things. So this is 50 bar, 350 C, for example. Leaching of ores, so recovery of very expensive and valuable metals using hydrofluoric acid. So this, we had to make it from a special material that resisted those acids. There's talk from Dr. Ismail about desalination. So this is a desalination rig that was designed specifically for this customer. You can see we often develop a three-dimensional model and then actually produce the equipment shown on the right. And this is at very high pressures, 250 bar and 500 C.
Sure, Mr. Tim.
Yeah.
Time is up.
Okay. I will take just one more minute if I may, and then complete.
Yes.
Okay, thank you.
Oh, okay. Please.
Okay. If I can make my button work. And then here's an example of what I mentioned, the municipal solid waste upgrading. So as I scroll through the rest of these, again, my main purpose here today is just to give you a few examples of some of the things that can be done with PAR equipment. And one of the things that I'd like to just leave you with is, if you have a question or you have an idea or you have a thought, please don't hesitate to ask. Sometimes we can either help you with an application for a piece of PAR equipment, or we can refer you to someone else who may be able to make something for you that would be more applicable to your research. And then I'll just conclude by saying I also want to give my thanks to PT Thermolindo. They are our local distributor here in Indonesia. We've been working with them for 35 years or so, and they provide very excellent service, and will be happy to help you with any questions that you have. So I'll stop my time there. Thank you very much.
Thank you, Mr. Tim, for your excellent presentation. And I think your products, your instruments, PAR instruments, most of them are related with our laboratory, because we have research related to the plastic. We have research related with the pyrolysis, biochar, and everything. And your explanation regarding to your products, it make an insight for us, for our researchers, of course, for their further research regarding to achieve some of research results. Thanks, Mr. Tim, for your presentation. The next presentation, I will let Pak Rahmat to present Hioki, okay? And time is yours now, Pak Rahmat. You want to stay here? Basically, you can present in a chair or in a podium, in the podium. Pak Rahmat very careful when interrupting the microphone. No worry, Pak Rahmat.
Thank you so much, Pak Tata. Good afternoon, everyone. I would like to thank you for the time given for us from HIOKI, and it is an honor for me to attend and speak at this BRIN event. And I would like to start by introducing HIOKI EE Corporation as our mother company. So HIOKI is a brand of measuring instruments. HIOKI established about 1935 and at Ueda City, Nagano. So our company have about 1,000 employees, and 1/3 is engineers, R&D. So we hope we can help to develop a measuring instrument for sustainability, and we have about 280 distributors around the world. Okay. Thank you. So this is our subsidiary companies worldwide, including in Indonesia. We have PT HIOKI Electric Indonesia, and we have 2 offices actually in Jakarta and Surabaya. And for your information, we would like to inform that in Jakarta, we already have the service laboratory for the repair, the instruments, adjustment, and do calibrations. And also, we have the training centers for everyone who wants to get the course about the power quality, about electric vehicle, battery measurement, and energy audit. So please visit our website if you already know. And so our domain of business to visualizing the conversion efficiency for electrical energy to various form of energy. Yes, so we know the energy form for electric energy and mechanical energy, thermal energy, chemical energy, the form of energy, and the change of the energy from electrical to another energy. People used to build equipment to change the energy form, and probably to make a move, we have the motor we use the electrical and get the mechanical energy, something like that. And also, for example, to chemical energy for electrolysis to produce hydrogen, and or the first vice versa, another energy to become the electrical energy, and all the conditions, the conversion, the energy conversion, Hioki have the measuring instruments to measure the whatever parameters needs to quantify the parameters value. So we have the power analyzers and data recorder, logger, data logger, and also this year, Hioki launched the electrolyzer analyzer, to analyze the electrolyzer to produce fuel cell. So I will talk about this later. And so electrical measuring instrument play key roles in every industry, helping to give the measurement value, and in order to achieve the green energy and to renewable energy from centralized to decentralized, and from carbon dependency, and we hope we can give contribution for the society. And in these occasions, I will introduce the Hioki solution for renewable energy and battery process measurement, the evaluation of power condition system in renewable energy generation, electrolysis cell analyzer, powder impedance measurement system, and battery slurry analytical systems. So the first we will see the evaluation of power condition system in renewable energy generations. We have the power analyzer, with high precision calculation of efficiency and loss. We can help to evaluate the power condition system of renewable energy generators, such as solar systems or wind turbines, simultaneously display parameters of reactive power wave, DC ripple ratio, unbalance factor, and others can be done for further analysis. Okay, so for example, we can see the load change, the occurrence of voltage and current drops at the inverter input when the AC load is removed. So we can analyze, for example, and other example when see the looking at this. The solar panel charging voltage increase and equates the battery voltage when there is no AC load running. So this is the example when we want to analyze the solar system, and of course the efficiency. So the PCS efficiency, from how much the power in, how much of power out occurs on the systems. And this is for the electrolyzer. So we have the product electrolysis cell analyzer, yeah, using ALDAS. We call it ALDAS, Active Line Device Analysis System. Yeah, so actually there is no need for any modification of the electrolyzer being measured. Just connect the source module to the cell power source terminal, and the source module will apply the AC current for measurement, and then attach the sense cable to the cell being measured and clamp the current sensor, and measurement can be started. Yeah, so the result, yeah, something like this, yeah. So we can see the IV curve and the NICU's plot for the impedance. So to analyze the electrolyzer from the liquid plus liquid plot. So for example, there is two similar electrolyzer, but the first is a new one and the second probably already used. So if we can see the difference of graphic for the resistance, so it indicates the cell degradation. So, and yeah, other example when we have two curve, so probably it indicates the catalyst, yeah, catalyst change, catalyst activity on the electrolyzer. And for another example, if there is huge curve, yeah, it indicate the reduced operating efficiency due to mass transfer resistance. And others topic, I would like to introduce you to powder impedance measurement systems. Five more minutes, okay. So we talk about the battery structure. So we already know about the lithium-ion battery with the liquid electrolyte, and other technology is the solid-state battery. So the electrolyte not using the liquid but the solids, so from powder. So liquid electrolytes require a thin insulating membrane here. So called a separator. If separator breaks, it can cause internal short circuits leading to the thermal runaway and fires. And additionally, liquid electrolytes are highly flammable and degrade with heat. Changing to solid electrolytes is expected to overcome this weakness. Moreover, adopting solid electrolytes broadens the choice of active materials for electrodes, potentially leading to performance breakthroughs. So this is maybe still in research, and probably can help for another opportunity for battery technology. Yes, so this is the equipment. So we have the pressure, the press fixture, and this equipment to measure the impedance, thickness, and pressure while controlling the compression state of the powders. And we will have Nyquist plot the impedance value relationship between ionic conductivity and Bach density. Yeah, we can see the graphic. So we will the system will calculate the density, ionic conductivity, and electrical conductivity. So the parameter we can get impedance, volume, resistivity, conductivity, ionic conductivity, relative permittivity, Bach density, thickness, filling factor, and porosity. So another equipment I would like to introduce the slurry analytical system. So slurry is a component or part to make a battery. So if we have the overview for battery process, we have the slurry here to stick to the electrode. Yeah, so this is electrode, and the slurry stick to the electrode, and the slurry components maybe depend on the type of battery, maybe NCA, and yeah, for the cathodic and anode. So the difference of the component of slurry make the different effect to the specific energy. Yeah, maybe the lifespan and the safety and the cost. And so we want to know the uniformity of the slurry when mixed at the machine, and we want to know the ratio resistive component by conductive materials on the slurry. So we have we calculate the time is up. So yeah, we calculate the DCR ratio and uniformity, and like this, and so we will get the we can analyze from mixing time and difference of conductive agent, and maybe relationship between conductivity and dynamic viscoelasticity. So with different dispersions. Yeah, okay. I think that's all from me. And this is the battery process and how Hioki instruments can contribute to help customer to measure the in the process. Yes, thank you so much for your time.
Thank you, Pak Ahmad, for your presentation. Dear ladies and gentlemen, I'm sorry, maybe I will still open the question and answer from you, and it will take some time from your interrupt your lunch, yeah. But I will let maybe just one session, question and answer from participant who attend in this room. If there is there any participant? Okay, in the back side. Any others? Participant want to? Okay, second participant. One more. Okay, the first two. Okay, please mention your name and your question will be pointed in to whom, right?
Okay. Thank you so much. Good afternoon, everyone. My name is Yedit. Actually, the question is for all the keynote speaker. The brief introduction is the renewable energy is the future that happening right now, right? We are agree of that statement, I guess. And I think it's really important to like this kind of renewable energy we have to thinking right now, because the future, if we not use the renewable energy, it will be something else. That's if we are planning to stay on Earth for a long time, I think we are should thinking about renewable energy. And then my question is how to make this renewable energy really sustainable, because this is our problem right now. The renewable energy is not really sustainable in the term of the usage. And then I mean, how the strategies in your point of view, for example, in your point of view, I mean, in your company point of view or in your own point of view, and how's your product to support this sustainable energy. Thank you so much.
Okay, it is clear enough for the speaker. Maybe Mr. Tim, here first. Oh, sorry. This one. Sorry.
I'm sorry, I'm not having good luck with microphones today. So let me make sure I understood your question. You said renewable energy is the future. What is our vision for, could you say that again?
Sustainable.
Yeah. My statement is renewable energy is the future that's happening right now. So the question is, in my point of view, the renewable energy is not really sustainable like right now. It's not really 100% sustainable. So in your point of view, how to make this renewable energy is sustainable, and how's your product support this movement? Thank you so much.
Thank you. I understand better now. So my answer to that question is very small steps. If we would have started from 50 years ago and imagined the idea of 50-meter tall windmills generating energy, everyone would have thought you were crazy. And now they're common. If you would have thought about the idea of running a car on a battery, the same thing is true. But now those are a part of millions of people's everyday lives. And all of those things happened because people like you did the research that it takes to develop the next small step towards sustainability. That's the beauty of research. It doesn't happen in a day, it doesn't happen in a year, but over sustained years and decades of effort by thousands of dedicated people, that's how renewable energy becomes truly sustainable. Will it happen in 2030 or 2040 or 2026? I think the answer to that is slightly different in many fields, but the continuous process of trying to improve and make renewable energy slightly more sustainable tomorrow than it is today, that's my vision how it becomes truly sustainable in the future.
Thank you, Mr. Tim. Pak Rahmat?
Yeah, thank you for the question. I think good point from Tim. So we can do small step first, and we hope that around the world do the small thing, and it's become a big thing. So we hope step by step we can achieve the sustainable future. And from HIOKI as the measuring instruments BRIN, we hope we can contribute to help and to prepare to give instruments to measure. So we can say that if we cannot measure, we can do. We don't know how to change. So measuring is one important thing, and we hope we can contribute not only by a company, but all of us, and we can change the world. Yeah. for renewable energy and get the sustainability future. Thank you.
Thank you, Pak Ahmad. Mr. Tim, you want to add something else regarding to contribution of participant?
Just very briefly, how could our product help with that? We believe that being a manufacturer of a tool is one way that we can contribute. And by providing excellent service and by customizing our product to meet the needs of where a researcher is in their research journey, the types of equipment we were providing 40 years ago are very similar to the types of equipment we provide today, but there are some subtle differences, and it's because, frankly, we don't think we're smart enough to go sit in a room and come up with the next new device that will revolutionize research. We listen to the people that are doing research, and we customize the equipment to what you need. And in some small way, we like to think that that's how we can best contribute to progress. Thank you.
Very excellent point of view
Thank
from
you so much.
Mr. Tim and Pak Ahmad, how the research, the things that we are doing now can achieve, can make the renewable energy, which is at this moment probably still not sustained, but it is expected at some time, nearly there, at near time, they can be more sustained, All right, thank you for Mr. Tim and Pak Ahmad. The second question from Pak Kapus, Pak Teguh.
Yes, I would like to ask a question for Tim. Thank you, Tim, for your excellent presentation. Actually, you are trying your best to manage with a broadened perspective and application, since you are mentioned in this conference, the audience is also coming from different background. So, Tim, many of the trend right now, nowadays, they talk about the hydrogen power on heavy duty vehicle. So since you are also pressure vessel specialized, and you also fabricators of the pressure reactor, so I would like to ask how your perspective and the readiness of the technology for the hydrogen tank, since the pressure is also high, around 300 to 700 bar, with some of the type of the hydrogen tank also fully wrapped with carbon fiber sometimes. So I would like to ask your perspective about this readiness level of this technology, and what is the new trend in like maybe 10 or 20 years later? Thank you, Tim. Yeah.
It's a very good question. I was at a conference in Edmonton, Alberta, Canada, last year. It was an environmental conference, and they had a full-sized heavy-duty vehicle in the exhibition hall that had a hydrogen tank on the back of it. And it was exactly as you describe. It was fiberglass with carbon fiber reinforcement directly behind the cab. And I thought to myself, I would not want to drive that truck. Honestly, the idea of having 700 bar, I think they said it would hold 5 kilograms of hydrogen. That's incredible to me, to think that that much hydrogen could be held in a pressure vessel that was maybe 50 or 100 liters in size. So because of the manufacture of that type of pressure vessel, frankly, I'm not qualified to really comment on it, because all of the vessels that we make are made from metal, and it's really just not practical because of the weight of such a vessel. To make it out of metal, it needs to be fiberglass or carbon fiber or something like that. So the safety mechanisms in place for a pressure vessel like that are really outside of PAR's purview and outside of my experience. But I think just some type of physical protection for that, or location of that, or perhaps trying to minimize the size, and there may have to be infrastructure requirements for more frequent refueling to keep the size of those tanks as small as possible to minimize the risk. I'm afraid I don't have a very good answer, but all of the things that you raised are, I think the big questions in the field right now is how do you manage this from a safety perspective? I'm sorry, I can't do better than that.
Thank you, Mr. Tim. Ladies and gentlemen, I think we were limited by the time. I will not open for the second session, but you can see in the outside, oh, sorry, lanjut. Oh, sorry, there is a question from online participants, yeah? I will let them speak directly or they put their question into. Oh, okay. Okay, thank you, Panitia. Okay, so I will open for the online participant, yeah? Is there any participant from online raise their hand? Ada nggak ya dari online? Okay, one offline, okay? Please raise, yeah, in the right side of podium. Yeah. The mic.
Yes. I would like to ask for Mr. Tim. So yeah. So I would like to ask about more technically. In one of your slides, you explained about the pyrolysis process from the plastics. So I have one simple question. How can you deal with the dioxin that usually occur during the pyrolysis between 300 until 1000 C? So how can your pyrolysis reactor deal with the occurrence of dioxin? Thank you. Dioxin.
Dioxin. Yeah, dioxin.
Yeah.
So I'm afraid that I'm going to give you the same or a similar answer that I just gave. So I am not an application specialist and can't specifically comment on the exact chemistry of that process, but we deal with customers that are working with very toxic and very hazardous chemicals regularly. So first of all, the location where the equipment is used is critically important. Most of the equipment that we sell is used in a fume hood or another suitable location where any toxic fumes or hazardous chemicals would be routed appropriately. And we rely on our customers and their health and safety departments to determine what meets the criteria for a safe location for the application that they're using. So if in the case of a continuous process where you're feeding gas and then having gas evolved, the scrubbing or the management of that gas would just be downstream of that, but it would need to be done in a location where that's appropriate.
Okay.
I hope that answers your question at least somewhat.
Yeah, I think it's very clearly answered, yeah, his question. Okay, there is question from the online, from Adin BRIN. The question is, how does the integration of HPHT testing influence the standardization and certification of renewable energy products? Maybe this question related to Mr. Tim, yeah? Oh, I think the second question also is still related with Mr. Tim. How does HPHT testing contribute to the development of the next generation PV?
So both very good questions. So the first one about testing, standardization, and certification. I'm not sure if I'm going to answer exactly the question, but I'll try. We are bound by very rigorous and strict requirements for our vessels because they are rated for high temperatures and high pressures and therefore present some unique safety challenges. We comply and are regularly audited by a number of bodies to ensure that our quality system and our manufacturing processes allow us to adhere to those standardization and certification bodies. Now, it looks like you're asking about the certification of renewable energy products. Really, that is dependent on the specific situation. So, for example, there was a slide about biochar production using a reactor. Well, that's just biochar at the end of the day, and there really isn't any certification of that unless the producer, that is the researcher, needs to comply with some standard after the production, which we probably really wouldn't get involved in. But for our equipment, we have to follow a lot of standards. And one thing that is nice is that there are some both North American, European, and global standards, so that it does allow us to have a single design that we can sell to various countries in the world because those global standards exist. And then secondly, about the development of next generation photovoltaic cells, I have to admit that I'm not sure about this, but one of the common questions or one of the common applications is material development, material science. So I know that there are researchers out there that are looking to develop the next generation of materials for solar cells, and what role high pressure, high temperature research is playing in that development. I'm not exactly sure right now, but if there's a specific application, I think our contact information is available. If you have a specific question about a certain material, please feel free to send me an email. And that goes for anyone here. I'd be glad to try and answer your question or talk to our technical staff to get you a more specific answer. Thank you.
Thank you, Mr. Tim. Is there any other question from the online? Okay. Okay, dear gentlemen, I think I'm going to close the question and answer session. I'm sorry for interrupting your lunchtime. Thank you so much for both speakers, Mr. Tim and Mr. Ahmad. Yeah, and if you still have a curious question, you can go to outside. Yeah, they have both outside, and you can discuss further regarding to your question. Again, thank you so much for our participant discussion. I'll give this mic back to the MC. Thank you.
Thank you. Please give applause for this session, an industrial talk sessions. And as Dr. Tata mentioned, please visit the booth because it's a very rare opportunity to have Tim and Pak Rahmat here with us. And they can help us to understand more about their products and also, other insights. So once again, please give applause to this session. And we would like to again deliver souvenir as a gratitude from BRIN to the speakers and moderator. Again, Professor Chu. Okay, we'll wait for you to take some drink. Okay, please come to stage to deliver the souvenirs for our speakers. And Par Instrument and Yoki Electric Indonesia also support this conference very generously by being our sponsors. So again, not only as speakers of industrial talk session, but also as our sponsors. We're very grateful to have you supporting us. Hopefully, you will continue to support us for next year's conference. Thank you so much, please, for sharing and joining since yesterday until today to share about not only the product but also potential research in the future using product of Par Instrument. Actually, to me, I have emotional bonding with Par Instrument because I've been using Par Instrument since I was taking my master and doctoral course. Even until today, when I conduct my experiments, I'm using Par Instrument. So to me, the team is like a celebrity. To me, the team is like meeting. Also, Yoki product. In the upcoming few days, we have a new Yoki product also in our laboratory. We hope that we can use their instrument to help us supporting our research. And then, of course, the moderator, Dr. Tata, also come all the way from Jakarta to be the moderator of this session and for chairing the discussion very attractively. Okay, let's have group photos. you so much. Please give the warmest applause for Industrial Talk. Please return to your seats, sir, and let's continue to have a chat during the lunch session. All right, ladies and gentlemen, our morning session has concluded. It's time for us to have a break as we prepare for the next parallel oral session. I would like to remind you once again of the conference rules, but maybe I don't need to read again. Maybe can you show conference rule, just previous one? Okay, too far. Okay, this one, but I'm not going to read them again one by one. You can just take photo or screenshot. And because I already show you in the morning. So, okay, let's move to the next one, the list of room. Okay, so for the list of room, today we have two parallel session, offline and online. For sustainable energy, offline is snorkeling room, upper ground, one floor above this floor. And for MSTQ in manufacturing is in ballroom, which is here. And then for online, we have two topics, sustainable energy, room 1, and sustainable transportation, room 2. So please make sure you join the correct room. And since we have delays in the morning session, okay, we need to move the parallel session to 1:15 p.m. So we have around 30 minutes for lunch. I hope it's okay. Please adjust accordingly. And make sure you join the designated room. Let's get ready at 1:15 p.m. Let's do our best, okay? And two last reminders. First is that there is an awards recognition that will take place during the closing session. And it is expected to be around 3:30 to 4 p.m., the awards recognition. And there will be 5 winners of full paper and 5 winners for the presentations. So total, we will have 10 awards with interesting gifts. So stay tuned and do your best. I just being whispered just now for online session special because they're joining from, not from here. They will start at 1 p.m. So for online session, you can start at 1 p.m. But for offline sessions, since we need to have some time for lunch, we will start around 1:15 p.m., okay? And then one more reminder again, please visit the exhibition booth from Power Instrument and PT Hyoki Electric Indonesia, offering plenty of information about their products that may interest you. Don't miss the chance to explore their booths. Be sure to check them out. Right, now please enjoy your lunch and see you soon.